Hello everybody and welcome back. I hope you're all doing well. We're going to continue looking at the open paper from 2011. We're in the middle section, the B part questions. There's 4 of these. They're a little harder and they're worth a few more marks. So what have we got for B1? Arthur is driving to David's house, intending to arrive at a certain time. If he drives at 60 kilometers per hour, he will arrive 5 minutes late. So after the time that he wants. If he drives at 90 kilometers per hour, he will arrive 5 minutes early. If he drives at n kilometers per hour, he will arrive exactly on time. What is the value of n? Okay. So I don't know how far he's driving or what time he's specifically looking for, but I know that these are going to be related to speed because there's this nice relationship. Distance is speed times time, or speed is distance over time, or time is distance over speed. So I might say something like, let's say, who is it? Arthur or David? Arthur. Let's say Arthur drives d kilometers and wants to arrive with time t in, well, they say 5 minutes, so we could keep minutes, but then we're going to have to convert all our kilometers per hour into kilometers per minute, or we could change 5 minutes into hours. It's entirely up to you which one you want to do. I'm going to stick with minutes. So then d over 60, which is the time it's going to take, so d over 60 kilometers per hour. Actually, 60 kilometers per hour. How many hours are in a minute? So times 1 hour. 1 hour per minute. Did I just say how many kilometers in a minute or something like that? I don't know. There's 1 hour per 60 minutes, so we get 60 over 60, or 1 kilometer per hour is 1 kilometer per minute. Similarly, 90 kilometers per hour, you're going to multiply by 1 hour per 60 minutes, and you're going to get 90 over 60, or 3/2 of a kilometer per minute. Alright, so now everything's in terms of kilometers and minutes. We're good to go. So we know 5 minutes late, which would be t plus 5, is the distance traveled over 60, well, not 60 anymore, 1 kilometer per minute. So t plus 5 is d. We know t minus 5 is d over 3/2 of a kilometer per minute. So that's 2/3 d. And I suppose we could subtract these and figure out d by itself and then figure out t. Or I suppose we could add them and get 2t is equal to 5/3 d. And so if he wants to arrive just at t, divide by 2, so 5/3 or 5/6 d. And so if we just want to arrive at this time, having traveled this distance, we need to go 6/5. We need to divide by 6/5 in order to multiply by 5/6 kilometers per minute, but n was in kilometers per hour. So that's 6/5 kilometers per minute multiplied by 60 minutes per 1 hour. 60 divided by 5 is 12 times 6 is 72 kilometers per hour. N is, 72. All right. So there we go. We've shown our work, and yeah, I'd say everything's nice and neat. Of course, you could do the question, as I mentioned, differently by talking about t hours. T is time in hours, and instead of converting kilometers per hour into kilometers per minute, you'll have to convert the 5 minutes here into 1/12 of an hour. But I suspect similar reasoning would do just fine. And of course, you could solve for d on its own if you wanted to. D 1/3 D would be 10 minutes. Well, 1/3 D would be 10. And so then you'd figure out D is 30 kilometers per hour. And then you could figure out your time from there. And that's fine, but everything worked out quite nice and neat. So let's get a fresh sheet of paper for B2, and I'll see you for that in the next video.